Okay, everyone, you should be on day 4, arc length. And I know some of you may say, well, we did arc length on Wednesday in class, and you are correct. If you remember right now, formula we used for arc length was the measure of the arc over 360 times the circumference, pi d. Here's the issue we're going to have today, though. When you plugged in for the measure of the arc, what did you always plug in? You always plugged in a degree measure, degrees, degrees, degrees. But as you saw yesterday in class, sometimes an angle may not be measured in degrees. It may be measured in what we call radians. So we need another formula that says, okay, if the angle is in radians, the central angle is in radians, I can use this formula. And the formula we're going to use to find arc length when the angle's in radians is the following. Theta equals S over R. And let me talk about what all three pieces mean. Let's get R out of the way. Most of us can maybe already guess R is the radius length. S here. Come on. S will be the arc length. So most of the time we'll be solving for S here. And then finally, theta, that is my angle in radians. Again, this formula can only be used if the angle, the central angle, is in radians. If it's not in radians, if it's in degrees, then I'm going to have to revert back to my formula I showed you guys on Wednesday. Now, a different version of this formula you may like a little bit better. Because most of the time, like I said, you're going to be asked for what the heck's the arc length. And it'd be nice to have a formula where it was already S equals, the arc length equals. So if you take a look at my formula I just gave you guys, theta equals S over R, how would you solve that for S? Well, you'd get R out of there. How do you get R out of there? You multiply both sides by R, and you end up with the arc length S is equal to the angle in radians, theta, times the radius. Some kids like to call it SOR. All right, so now we have two formulas to find the length of an arc. One is if the measure of the angle is in degrees, and the other is if it's in radians. And we'll talk at the end, is it really necessary to remember both? No, we'll talk about that at the end, how you can get away with just knowing one of them. All right, so here we go. First couple examples here, find the arc length S. All right, well, if you take a look right now, look at my angle. That's not degrees, that is in radians. So I want to use my formula, S equals happy face, nope. S equals theta R. Okay, again, I want to use this. That one I gave you guys on Wednesday, that formula, which is measure over 360 times circumference, it's useless here because the angle's in radians and I need degrees for that formula. So you just keep going. S equals theta, which is pi over 3, times my radius, which is 5. And if you look at the directions, round to the nearest hundredth. So S will be equal to, calculate that on your calculators, 5.24. And like I've been preaching all unit, the original diagram had units, so does your final answer, 5.2 centimeters. Next one, going through these pretty quickly now. Again, take a look. 10 pi over 9, that's in radians, so I want to use the arc length formula, S equals theta R. So S equals 10 pi over 9 times my radius, 27. You guys can crunch the numbers on your calculator, round to the nearest hundredth, and we are looking at 94.25 meters. All right. So again, angles in radians, I want to use S equals theta R versus the other formula from Wednesday. All right, so now we get to something like 3, where now I want to know what is the angle? What is theta? All right, and if you take a look right now, 8 pi, That's my arc length. And 16 is my radius. Guys, I could use either formula right now. I could use the measure of the arc over 360 times pi d, or I could use S equals theta r, because my answer has to be in both radians and degrees. But if you think about it right now, and I have it written up on the board, if you take a look right now over to the left of the Promethean board, I have both formulas written up there for you already. Which one is it probably easier to use? If I were you, I would probably use theta equals, S equals theta r. It's just a little bit less variables, a little bit easier to deal with. All right. S is my arc length, so I plug in 8 pi. Theta is what I'm trying to solve for, the angle. And my radius length is 16. So how do I get theta all by itself? I divide both sides by 16. All right. This answer, remember, because I'm using S equals theta r, my answer will be in radians. So theta equals, and as we learned from yesterday, keep the pi in your answer with radians. Pi 8 divided by 16 is 1 over 2. So in radians, that angle is pi over 2. If you read the directions, though, it says in radians and degrees. So in degrees, so in degrees, now are you going to have to get that other formula I have up on the board on the top, measure over 360 times pi d? We don't need that. You guys have the ability from yesterday's class to take radian pi over 2 and convert it into degree form. Look on your formula sheet, look back in yesterday's notes. What do I have to multiply pi over 2 by? I need to multiply it by 180 over pi. Pi's cancel out. I'm left with 180 over 2, and that is in degrees, 90 degrees. Okay, 90 degrees. All right, next one, same thing. All right, find the angle in radians and degrees. So I'm going to use S equals, maybe I am, there we go, S equals theta r. I'm going to say my arc length this time is 15 pi over 7, and that's equal to theta times my radius, which is 5. Divide both sides by 5. And remember, this will get you the radian measure of that angle. So you want to keep the pi in your answer. So a lot of you guys should go to your calculators right now. Get a fraction template, 15 over 7. Get another fraction template divided by 5. All right, leave the pi in your answer if we're looking for radians. And theta will be equal to, what do I have here? 3 pi over 7. It reduces down to. And I'll give you guys a minute right now to convert that into degrees. It will come out to be a clean decimal here, so you can just round your answer to the nearest tenth. So take 3 pi over 7, put it in degrees. And in degrees, it should be 77.1 degrees, rounding to the nearest tenth. All right, moving on to the next one. Sorry I'm not with you guys today. Usually on this example, I like to bring up some Google images of a pendulum for a clock, because some of you kids, some of you youngsters may not know what it is. All right, pendulum of a clock. I'm not going to do this any justice one bit, but the part that hangs down there, all right, and swings back and forth on a clock. All right, going back and forth. Has an angle of 2.5. Hey, radians. So the angle is in radians. So I'm probably want to use S equals theta r. Travels through an arc of 50. So there's my S value. Find the length the pendulum. Now, it doesn't come out and say the word radius, but the length of the pendulum, if you can take a look here, is the radius length of this circle that's being formed when the pendulum goes back and forth. All right, so my arc length was 50. My angle in radians is 2.5, and I multiply that by the radius. Divide both sides by 2.5, and we end up with 20 centimeters. All right, all good there? All right, next one, if you want to try that on your own, go ahead, pause the video, because I was going to have you guys try it in your groups on your own, so go ahead, pause the video, I'll write the workup, and then replay the video, push play again, and then see if your answers came out to be correct. So go ahead and pause the video for number 6. So you should have used S equals theta R. The arc length is 24.5. The angle in radians is 3.5. You're looking for the diameter. I don't know if anybody caught that. So let me solve for the radius first. The radius was 7. So if I want to find the diameter, I take my 7. Oh, good. There we go. Take my diameter. Come on. And take 7, multiply it by 2. So the diameter, this is working perfectly. The diameter came out to be 14 units, centimeters. Okay. All right, last one. You can read through it. We got a cart traveling on a circular path. Radius is 2.4, 165 degrees, counterclockwise direction. What's the length of this arc right here? All right, so we got a choice now. You see that the angle is 165 degrees. So if you wanted to right now, we could get the other formula out from Wednesday that says the length of the arc is equal to the measure over 360 times pi d. Or now, here's what I was talking about earlier in the video. And that is, do I really need to remember both? No. If you're a big fan right now of S equals theta R, you can use that the entire time. You just got to make a little adjustment. And that is, all right, if you're going to use theta S equals theta R, theta's got to be in radians, but it's in degrees. Is there a way around that? Yeah, you're darn right. You could take 165, this is what we did yesterday in class, and convert it into radians. So you could take 165, multiply it by pi over 180, reduce 165 over 180, keep the pi in your answer, and plug it in for theta if you want. All right, so you do not have to remember both formulas. If you're S equals theta R, fine. Just make sure you can convert degrees to radians. If you like this formula better, keep that formula, but make sure you can go from radians to degrees because that's what you have to plug in for this measure. All right, so take a minute, use either formula, and calculate to the nearest tenth of a meter the counterclockwise distance from A to B. And you should be getting 6.9 meters. Okay, so just know, guys, you have two formulas for length of an arc. You have one that has to be in degrees to use and one that has to be in radians to use. If you want to just remember one, that's fine. Just have the ability to convert. If you want to remember both, fine too. All right, it's really an individual decision what you guys feel comfortable doing. Do you want to convert all the time, or do you just want to remember two formulas and you don't have to worry about converting? That's a choice you can make. So start on the next couple pages. Save any of your questions for Monday when we meet again. Thanks, everybody.